Final lecture. All right. I'm going to do this in a couple of parts. We're going to talk about data science, and then we're going to talk about sort of my principles of it, and then maybe some stuff about the future. So what's next? I mean, here's the thing, right? There's all these people out there that are like learning data science in a week for $30, and you're like, wait, some guy did an endowment, and I got to do 4 years, and like this was hard. Like, what's going on? And why don't I know all of data science yet? So it turns out data science is really big and complicated. And what most of those boot camps and things like that are teaching you is actually a pretty small part of data science. So specifically, it's about training models. So sort of that line fitting that we did at the end. But a lot of times there's not enough thought about why or what's really going on, or if your answer is really true. And you'll notice that a lot of this quarter has been about the machinery, sort of learning the basics, which we did pretty quickly. And then a lot of it was about really trying to reason about uncertainty in a careful, principled way, right? So in case none of you know, this is a funny joke because that's Bayes, who you may have heard of in Bayes' rule, and there's a classifier called naive Bayes, and so this is Bayes being naive. Jokes are better when you explain them, right? I also didn't really define data science in this class. So most classes start with like laying out what they think data science is or what it's for. And we sort of blew past that and jumped right in. The reason I didn't do that is because I wanted you to have a pretty firm grounding in what we were talking about so that I could then like back into what I think data science is. So, let's talk about the big picture here. This is what data scientists all do all day. So this report is a couple of years old now. They have an updated version, but now you have to pay $30 to see it, and I don't think it's changed that much. So if you look at this, the vast majority of time is spent cleaning and organizing data. So we've done some of that in class, and especially in this last project, you notice that you went through and like had to turn date times into days and then order them and then split groups. And like, there's all this like mechanism there. That was real data, but real data also gets much messier and more complicated. So that's the majority of the time. Another big chunk of time is actually getting the data. It turns out that it's not always as clean as just being handed a CSV like you've had in this class. And then actually going through and doing the modeling part that many of the boot camps talk about is like a couple of % of the time. For me personally, this is not quite how it is. I would put more time on trying to understand the question and getting frustrated. That's parts of the circle that are missing for me. All right, so then if this is what people are doing all day, what's the goal, right? Like, why are we doing this at all? So this is from a book that Kirill Eremenko wrote. I recommend the book. If you do read it, it's like a super easy, light read, and it's got the best definitions of what data science is and what it's like to do data science that I've read in the first half of the book. The second half of the book is terrible. You should just stop at like chapter 8. So once it stops being about sort of what data science is and starts being about math and stuff, his math explanations are just bad. But this is one way to think about it. So the first thing that you do is you have to figure out what question you're answering. So you've seen that a little bit in this last project where you start with a goal, and the goal might be something as simple as, how has policing changed because of the pandemic, right? And then what you have to do is you have to start to think about the scope of that. So you're like, okay, I can't do policing, but I might be able to do police calls because that's what I have the data for. And I'm only going to do San Diego. And so you start sort of clarifying the question. identifying the question and getting it really crisp is actually a big part of the job. Then you pull down the data, right? So you have to find it, source it, clean it, completeness, anomalies, QA, all that stuff. Then you do the part that we do a lot in this class. So building models, testing hypotheses, all that stuff. Visualization, right? We've done a little bit of that in this class. So looking at your results. And the last step is documentation, or turning it into a product, or building a user interface, user experience, UI, UX. That's really about trying to take your results and get them out of your brain and into other people's brains. Okay, so it's not a linear process. You don't go 1 to 5, right? You hop around some of things, but this is really overall the goal. And I think we spent like all of our time in 3. You're going to be spending, if you keep going in the data science curriculum, we spend a lot more time on 2 and 4 as time goes on in the lower division classes, and then 1 and 5 really come in the upper division classes. So in case I haven't said, right, for me, data science is really science in the service of decision making. So helping people make decisions. That's a big space, right? Helping people make decisions with math is super vague. It could be just about everything, but I think generally this flow is pretty helpful. There's also some other parts of data science we didn't talk a ton about in this class that I want to hint at. So one of them is ethics, right? There's a bunch of books that have come out recently. Algorithms of Oppression is pretty good. I really liked Weapons of Math Destruction. That's MATH by Kathy O'Neill. But they're like popularizations. They're like nonfiction chapter booky kind of things. So no math or anything. And they describe times when data science went bad and hurt people. There are a lot of them. And I went to some of the senior presentations, the DSC 180 this morning. They had their final presentations. And there was a group that looked at PredPol, a predictive policing algorithm that LAPD used, and showed they rolled it out like precinct by precinct, and they showed that it dramatically increased racial disparities in policing when they used this algorithm. So things like that are really important to understand. So first thing I want to say about ethics is that it's a practice. It's really checking in and saying, hey, do the things I'm doing, do my actions align with my values, right? I also think it's good to have a checklist approach, and these are a good start for a checklist. This link down here at the bottom is a really nice paper, but to run through them quickly, you want the consent of the people you're doing work on, if at all possible. So if you're studying people, they should know that you're gathering their data and what their data is used for. You want clarity about what's going on, right? So who's using the data? How is it getting used? Consistency and trust is a big one. So making sure that different people get similar experiences and that things are as people expect them to be. Control and transparency is about people being able to opt out, or people really being able to figure out what's going on. So I think one of the times people get really angry is around control and transparency is when they don't have it. For example, the Facebook feed, when they go and tweak something and everybody's seeing different results or whatever, people get very angry. And you got to think through the consequences, right? Often you can have a perfectly benign set of things, but you set up a thing that a system people can abuse. So a good example would be Reddit. I think often the core platform does the first 4 pretty well. You know what data it's gathering, all that kind of stuff. You can opt out. But the consequences of that platform have been enormous and not well thought through. And so that can be a disaster too. There's a quote I really like about why ethics is so important in data science, and it's that data is this really incredible lever arm for change, right? You have this enormous ability to impact things. And so what we need to do is make sure that the change that is coming is the change that we want for everyone, right? The change that everyone wants to see. And also often that's not true. There's going to be a class coming up. We actually just hired somebody who's going to teach a data science ethics class, and I'm super excited about it. So stay tuned. Okay, changing gears a bunch. We're gonna swap around on things. This is a plot showing the number of gun deaths in Florida over time, and Florida in 2005 adopted this stand your ground law, which changed the rules around civilian engagement and let people shoot not just when they were fearful for their life, but just because they were fearful for their property or something else also. This plot is terrible. And the thing is, you look at it and you immediately think that in 2005, the number of murders dropped. But what they've done is invert the y-axis, which takes a minute to see. And so this is actually a large spike in murders that happened after the change, right? This is a short way of saying, I think that visualization is super important and can be done in incredibly misleading ways. There are entire degrees people get in visualization and how to communicate data effectively. And we have classes at UCSD just devoted to that topic. In this class, we kind of glossed over it. We talked about what types of plots are good for what, but not about how people sort of understand data and how to communicate it well. So here's another example. And this is an example that I think is not misleading exactly, but it shows the power of good visualizations really nicely. So there's this group that does monthly makeovers. So they have data that are plots that they don't like and they fix them. So at first this plot doesn't look particularly bad, right? It seems sensible, everything's laid out. But if you have a question, it can be really hard to figure out. So for example, what field has the largest gender gap? When you do that, you start hunting around and doing math. And then what if I said, what about as a percentage of the overall group, right? So now you're just totally lost. So this is the way they reworked it. And sort of immediately a lot of things come out, right? So you can see natural sciences, there's no gap. This becomes very clear that it's a large gap and that it's a male-dominated field. This is a female-dominated field. It's easier to get the information out and it's much more clear. So this is a huge space. There's a book I normally recommend to students called The Visual Display of Quantitative Information by Edward Tufte. Normally I tell students to go look at it in the library though, because it's got a bunch of color pictures and so it's kind of expensive. So maybe next time we're all back on campus, check that one out. All right, when we're talking about data science and the hodgepodge of things, I also want to talk about privacy. So data privacy is a thing that has become a lot more front of mind for people recently. Things like the credit union hack, which actually wasn't even a hack, but everybody understands that the data privacy is increasingly important. As a data scientist, I want to give you a different perspective. I want you to think about data as toxic waste, right? So think of it as radioactive waste. Radioactivity it can be great. If you're powering a nuclear plant, you want what other people think of as radioactive waste. That's how you get that stuff going, right? It can be incredibly powerful to have nasty chemicals around if you're a manufacturing plant. I keep a lot of data that's very dangerous if it got out in the world. If it leaked, it would be an ecological disaster, is the analogy, right? But I also delete it when I don't need it anymore, right? I try to not collect things I don't need. I don't just have a bunch of stuff lying around because it's bad, right? If it leaks out, people's lives are ruined, right? So I want to talk about two sites in particular and kind of freak people out a little bit. I can't tell, that is super weird. All right, I'm gonna. Oh God, I'm gonna try to do this live. All right, hopefully you can see that, and then I'll grab the link. So this first one is it's actually in the Mozilla Foundation now, and it's Have I Been Pwned? And you can type in your email address, right? So this is my personal email address, and then I can see what leaks it's been in. And some details about them. So I don't even remember some of these sites, but like I gave money to Kickstarter at one point, and they gave away my password. Same thing for all these other sites, right? So like I don't know, Ticketfly, May of 2018, they gave away my name and phone number. One of the ones that you should know is lots of these give out your password. The biggest risk to you personally today is password reuse, and you should use a password manager to solve that problem. You can see each one of these password, right? Once that password and email's out, what happens is people try to use it on other accounts. So if you reuse your Kickstarter one on Netflix, someone will log in as you and they'll sell that account, right? God forbid you use it for your bank or your email and it's game over. So password managers are great, highly recommended. If you don't know what they are, just Google and figure it out. The other one I want to throw out about data and privacy is this. Google Maps has a timeline, and it tracks for me, because I have an Android phone, everywhere I go every day for years. So this is many years worth of data. You can see all these various trips. And horrifyingly, I'm going to pick a day I actually went somewhere. I haven't been traveling much. So on April 14th, oh, my dad went to the hospital that day. Yeah, so I drove up to my parents' house. I drove back down to the hospital, dropped them off. There was like that was my biggest travel day. Um, anyway, you can log in and see this at this same site, and I find it alarming how much these companies know about us. So anyway, there you go. All right, data. So that's my sort of overview on data science and stuff, and sort of where we're at. I want to spend a couple of minutes talking about my principles of data science. So there is I wrote this down as an article, but I want to go over just a couple of things that I want you to keep in mind as you go forward and use the things you learned in this class. So one of them is, and I think this is just generally true, that changing your mind when you find new information is a good thing. So often you hear politicians like flip-flopping or people not being true to their beliefs. But the fact is, like, it's totally okay to say, oh, I don't think that this pandemic is that dangerous. And then you get new data and you say, oh, now I do. And then you get more data and you can change your mind again. People who shame the World Health Organization for changing their mind on masks, like, okay, maybe they were slow to do it, but it's good they changed their mind. They got to the right answer, right? So new data should be able to change your mind about beliefs about the world. It's not just data science. I think that's just generally true, but especially in data science, if you gather some data and it disproves what you thought, you should maybe stop believing that thing. It's very tempting to say, oh, well, it must have been bad data or a bad analysis. I'll throw it out, all the rest. You should think carefully about that. All right. This is another one that we didn't get to in class and we often put off, but I think it's really true. Kaggle competitions and stuff really emphasize how rad deep learning is, which it is, and how tuning parameters and all this stuff is like the most important part of data science. And I think it's not. I think getting more data, understanding your data, and really being good at understanding exactly what it means will help you beat good algorithms every time. So, for example, Netflix has a recommender system, right? Their recommender system, they had a challenge years ago to improve it. And one of the biggest improvements people got was by pulling in outside data. So, so it turns out the data they had was good, but if you also pull in like tweets that people make about movies, you can learn a lot more with the natural language they describe it. So by pulling in other data, they were able to beat the other algorithms. So understand your data. I think a corollary of this is that you should start by solving easy problems with simple methods and not do these super complicated things, and make sure you really understand what's going on before you scale up to really complicated solutions. This is another one that's always true, but it's especially true in data science, is that when you're reviewing someone else's work or having your work reviewed, you should be very open to feedback and very comfortable saying, hey, that might not be true. Like, let's talk about if that were true, what it would mean, or whatever. So peer review is a way to get better. And you should definitely spend a lot of effort on that. A corollary of this is that you are responsible for the analysis you put out in the world. And if the person who reads your report or gets a recommendation or whatever is misled, they can make important decisions based on that falsehood. So I'm going to say a strong thing about this, which is if you publish results that are wrong, you lied to people unintentionally. And if they make decisions, let's say big business decisions based on those things, then you've made a mistake there, right? And you've caused that problem. So you need to be really careful. I'm kind of ignoring the chat, but Winston had a great question, which is about what happens if you don't agree on the details of the ethics. So I'm going to be really, people don't all agree, 100%. There's a lot of stuff going on in the world. There's clearly a lot of disagreement about politics and about what appropriate behaviors are and all these things. What I want for you, what I'm asking you to do, is to check in with your own values. And I want you to do actions that support your values, right? So this isn't about other people's ethics or whatever. This is saying when you go to work, if you're working for a company that has a contract with Immigration and Customs Enforcement, you have to decide if you feel good doing that data analysis or not. Reasonable people disagree on that question, but you need to be doing work that you believe in, right? Or at the very least, work that you think isn't doing harm in the world, right? If you think you're doing work that's doing harm in the world, I would encourage you to like find another job or wait tables until you can do it. Like just do something else, right? Like don't do that. Cool. All right. Part 3. This is, I think, the end, but it's a long part. So this is the future. I'm going to talk about your future and the future of data science. So the near future. I understand for many of you who are new to coding, this quarter was rough. It's going to get worse. 20 is a big step up. There is a lot more to code than we went over in this. What I'll say is, if you were able to do this, you're able to do the next one, right? Just because it changes a gear doesn't mean you can't keep cranking. I like this comic partly because the slope doesn't get steeper, right? It's just a long slope, and it keeps going forever. I still learn stuff all the time. That said, if you're going to take Data Science 20, especially if you're going to do it in the fall, I would encourage you to brush up a little bit on coding at the end of the summer. It's really easy to lose a bunch of that stuff and have it just go away. On the DSC10 website, on the bottom of the links and resources page, there's some stuff about classes that are like online stuff. So there's like some online classes, some workshops, some stuff like that people say, other students say have been helpful for them learning. If you have any recommendations, I'll put them there in the future, but really just spending a little bit of time brushing up and getting comfortable with it will set you up well for 20. Somebody asked if the website's going to stay up. It will probably stay up until fall because we're not doing 10 in the summer, I think. So you can always just email me. The site always exists, but it's going to be at like googlesites.com/some weird thing. Oh yeah, Jacob asked a great question about Jupyter Hub. Jupyter Hub is going to go away for you. That access will go away. So if you want your stuff, you should download it. And there's not a way to retain access. I don't know the best way to bulk download. I will find out. If anybody knows, post it in the forum. And then you can also run Jupyter locally, right? So I'll post a guide about that. Okay, so near future, lots of learning. There's also for some of you, one of the cool things is I have some folks that are just starting as data scientists, and I have some folks that are going to be graduating real soon here in some awkward Zoom graduation thing that we don't know what's going on. And most of those folks, like I heard this week from somebody that's in climate science and somebody that's in public health and all that stuff. You got choices, right? All of you are going to face choices when you finish undergrad, and there's a couple of directions you can all go. So one of them is grad school. In my mind, there's two really good reasons to go to grad school. And let me be really careful. To go to science, technology, engineering, and math grad school right after undergrad, right? So one is, if the job you want requires a degree, then you should go to grad school. So an example, obviously, like lawyers and doctors and stuff, but teaching. If you want to teach college, you have to get a PhD, right? If you want to teach high school, you have to get a teaching degree, right? So like any job where you have to get the degree or where it like gives you a huge leg up, that makes sense. The other reason to go to school right after undergrad is if you really like school and can afford it. And afford is a complicated concept. If you don't know what opportunity cost is, you should look that up. It's a really important concept that I think is not taught enough. But basically, you need to think about the loans, but also what you're missing out with on wages when you would be not working, right? And the fact is, right now, grad school is probably a better choice because the job market sucks. And so you are losing less money than you would have been a couple of years ago, right? Because it's hard to get a job. There are other good reasons to go to grad school, including visas and changing majors. I'm gonna sort of skip those, right? But I think if one of those two things are true, you might think about grad school. Grad school comes in two flavors, a master's and a PhD. It's becoming more common to do a master's before a PhD, but you can go straight to PhD programs in STEM fields. So master's degrees, usually 2 years. You write a thesis at the end, and it's really about getting specialized training. So it goes deeper into one topic than what you've done already. It tends to be career oriented, and it's significantly less time, right? I didn't make this graphic. I don't know that I totally agree. It's less money. And the reason for that is STEM PhDs are often funded. So I not only had tuition covered, but I was paid all 5 years of graduate school to do research, right? The payment is small. So like at UCSD, it's depending on your department, between $25,000 and $30,000 a year for an assistantship. But like, hey, that's way better than negative 30, right? Like, that's a lot of money. But a PhD is very different. It's a research oriented thing. So really you are trying to discover knowledge about the world that no one's ever had before. And so it's really about knowledge creation and sort of going all the way out to the edge of what people understand and then adding a tiny little bit to that. It's usually not a lot. 5 to 7 years is a good guess. If you don't come in with a master's degree, I'd say like shave a year off if you have a master's. Kevin asked if I think there's value in working before grad school. Yes. So huge value. The two biggest things, I took a year between undergrad and grad school because nobody let me into grad school the first time. And also I had a girlfriend that was a year behind me in school and I didn't want to leave. Right. I'm super thankful for that because I saved up a ton of money. So I lived like a student and saved like 80% of my income, and it was awesome. Because then I had this cushion, and when my car died in grad school and I was earning very little money, I could like fix my car, right? The other thing is it helped me to think about my PhD as a job and to really to understand some about how jobs work. So I'd had some jobs, but like to work for a year, you sort of, I don't know, work is different than school. And I'm glad that I had that perspective when I went into the PhD. A bunch of questions here. So how hard is the application for straight to the PhD from a bachelor's? I don't know. I am not up on a lot of this stuff. You should totally ask other professors. I applied for grad school forever ago and in a different field, and I don't get to be on those admissions committees, and I don't know. Somebody mentioned that you do not generally get funding for master's degree. That's correct. So PhD generally does. Sometimes it's through teaching and sometimes it's through research, right? So you have a job, and usually it's like half-time job, half-time school. Yeah. Somebody asked if there's a limit to how long you work before going to grad school, and not really. Like, one of the other reasons people go to grad school is career change. So the master's in data science that we have at UCSD is meant for working professionals. So it meets like Friday and Saturday, and it's really designed for folks that are not data scientists, but like maybe have been a developer for a long time and want to transition over. And so many of them are pretty far along in their career. They've been coding for 10 years and they want to change or whatever. So one thing that I got a specific question about was about how to choose what to go to graduate school in. I don't have a strong opinion about this, except that if you have an undergrad degree in data science, you might not think about getting another degree in data science, but moving around a little. And there's a couple of reasons for this. One of them is you already know a lot of data science. So there you go. The other one is Comte in 1857 made this graph that's the hierarchy of sciences. Obviously, it's not really true, but there's this idea that like math is the most sort of fundamental, and the theoretical physics, and then like applied physics, and then maybe like really applied stuff, and all the way up to the social sciences, right? So there's this continuum of abstraction. So math is like the most theoretical, most abstract, and then sociology is the most like hands-on, data-driven stuff. In general, when you do a master's and especially a PhD, everything goes up one level in abstraction. So if you really like doing physics, then you probably don't want to get a PhD in physics, because people who are getting a PhD in physics are like studying about physics, right? They're like doing one more level up. So the mistake I made in graduate school the first time is I thought I wanted to do applied math. And so I applied to applied math programs. But it turns out what I wanted to do was do math. And so I was way better off in a physics program, because that's where you actually do math, if that makes sense. The other thing is, you can apply with an undergrad degree in data science just about anywhere. And the reason for that is most labs and programs, especially if you want to go into a PhD, they're desperate for folks that can code, do machine learning, all that stuff, right? So if you show up and you're like, hey, I can code, I can reason about uncertainty, I can do math, and I want to be in this linguistics program, they're going to look at you and be like, whatever, you'll figure the linguistics out, like, come on in. That's probably an overstatement, but I think that's often true. There's a good question in the chat about prestige and how it works for PhDs and masters. So masters is often kind of like undergrad, kinda. For the PhD, it's not at all. So for the PhD, every field has its own ranking. So like I did my degree in acoustics. There are like 3 good schools for doing acoustics, and then a couple of like everywhere else is not as good. But they're not what you'd think, right? Like one of the best schools is Brigham Young, which is not a school I think of for that stuff. So it's super specialized, and much more than like the general undergrad rankings, you know? So you know, the good schools for data science are not the good schools for biology, are not the good schools for chemistry. And even inside fields, like I did acoustics, but I went to Penn State. The Penn State was really good at physical acoustics, but really not good at medical acoustics, right? So you just got to know what you're getting into. All right. Somebody asked about being a data scientist with just a minor in data science. I don't know. So I'm really frustrated about this. One of the things I really wanted to have happen with this first graduating class is to have evidence that an undergrad degree in data science could hold their own with somebody who like did an undergrad in bio and then a master's in data science somewhere, right? And I wanted to see them get hired at like, you know, Uber and Twitter and all these places and Google and stuff, and end up doing a good job. And then we would have proof that like this program works. And because of the pandemic, I think that people are not getting jobs as much, and I'm really sad to see that. And so I just don't know like about the minor and if it's enough to do it. Yeah, I think in the chat somebody said it depends on your major a lot. I think that's right. I think you'll be able to talk your way in, but I think it just depends. Okay, there's another path, right? So we talked a lot about grad school. You could also get a job. So jobs are kind of awesome. They pay you money to go there and do data science all day. To get a job, there's this book that came out in March called Build a Career in Data Science. You should skip the first chapter because it's about learning data science. But there's a bunch in there about interviewing and skills and portfolios and resumes and all that stuff. And then there's a bunch about how to actually do your career. So how to get promotions, how to design projects, all that stuff. So I'm going to talk about skills. Oh, God. Oh, I disappear. I'm back. I had a funny keyboard button, I think. All right. Skills, projects, portfolio, and an interview. Yeah. Skills. Okay. So here's the thing. People get really hung up on the tools you know. So these are all tools I have learned over the year. Many of them are useless now. But a lot of the concepts were good, right? So learning these individual skills and individual tools, people think of it as this checklist, and I don't think that's right. I also think it's super weird that all the ones that I'm into at this point are the blue ones on here, but we're going to move on. All right. So instead, you should learn concepts. You should have a thing you want to do, and then you'd learn the ideas behind that. And then you pick a tool just as a way to learn those concepts. So here are the concepts I think are important for data science that we didn't really do. Querying, getting data out of a database, or sort of aggregating data, asking questions. SQL is the answer. It looked a little bit 5 years ago like there was going to be other answers, and then SQL just came roaring back. So I would definitely start there. If you do visualizations on the web, there's a JavaScript library. JavaScript is different than Java, called D3. Data-driven documents, I think, is the D3. So D3.js JavaScript. I hate front-end stuff, but people who are good at it do amazing stuff, and I deeply respect the web visualization folks. So like if you go to the Pudding or one of those, or like the 538 or any of the New York Times, when they have those awesome visualizations, that's all D3. Cloud computing. Cloud is someone else's computer, right? So it's computers that are out in the world that you get to use. Amazon, AWS, Amazon Web Services is the answer, but Google Cloud is increasing in awesomeness. So one of those two. Data exploration, I like Tableau. You're all going to learn GitHub later, but you should definitely learn GitHub. Scikit-learn is the machine learning one. And then for weird stuff, I'd recommend Python packages. Just Google and find a nice pip installable one. But in general, like think about the problem you want to solve, and then the concepts that underlie that, and the like individual skills will swap out over time as technology changes. Some of you asked about projects. Here's how to get a project going. First off, you just get going, right? Don't wait until you're good at it. Just start doing the thing. I know that you feel like you don't have the knowledge or tools, but you do. You'll get there. The second thing you do is you steal someone else's stuff. So you find a project, hopefully open source, and somebody said that's a lot on the concepts. You are not going to learn all these things. One of them is enough to make a career out of. So don't worry about it. So you steal someone else's project. So by that, I mean, you start with something like some questions out of project 2, or someone's open source project, or something. I really like some of the COGS, I think it's 108 projects. You start with one of those, and you start trying to like tweak it and understand it and apply it and all the rest. But don't start from scratch. Don't start with a blank sheet of paper. Start with other people's work and just give them credit, right? Make sure the legally you can do it, but steal their stuff. And then the last thing is build something that you want to have happen. Don't build something that you're not excited about, because you need to be able to be passionate enough about this to be like, oh, I want to code instead of going for a bike ride, right? And if it's not something you care about, it will never happen. And then what you need to do is you need to do good work and share it with people. That's how you do stuff, right? That's the sharing it with people is key, because that's how you get feedback. It's Cox 109, I think. Kaggle also has a lot of good stuff to steal from, and Data Science 96 actually has some good stuff. So, all right, this is a longer quote, but I'm going to keep rolling. Yeah, I'm going to keep rolling. Not enough time. You need a portfolio. You need a web presence. So I don't care how you do it, Twitter, Medium, LinkedIn, but have some professional social networking and some GitHub stuff, maybe a personal site. And the reason for that is you need to show off the projects that you've done. So this is Scott Cole. He graduated a while ago. This is a screenshot of his personal homepage. And the thing I love is this like burritos of San Diego. Like, obviously you're like, what is that? You click on it and it's this cool interactive dashboard where you can, like, I don't know, sort by temperature rating, and like he and his friends tasted all these taco shops, and it's super fun, but it also shows that he can like do some analysis and build a dashboard and things. So, this is a little ways off for most of you probably, but when you're getting ready for an interview, you really need to prepare for it. Interviewing is a skill. I taught a class in it last quarter, but there is coding on whiteboards during interviews, so you need to have done that and practice that. And you need to read about how the company you're interviewing with does interviews. So Glassdoor is a website where you can look up information about that. Tech companies can be really weird with how they do interviews. So definitely do prep work on that. So that's the future. Except, so this article came out, a year ago, and it says radical changes coming to data science jobs. And what does it say here? So a calculator was a person back in the day, and a webmaster was a hot career. So what the argument here is that the levels of abstraction are changing, right? Compiler design, like, can you imagine doing that, right? Or all the rest. So data science is disappearing as a job title. Oh no. So what does that mean really? So I like the webmaster analogy. 20 years ago, everybody was a webmaster. They did everything from like designing the physical computer, hosting, designing the web server, code, writing the content, doing the graphic design. That's like 12 people's jobs now, right? So specialization happened. You're going to get specialization happening in data science, and I think these are some good places to go. An industry specialist, understanding a field, so an industry, or it could be a linguistics or climate science or whatever, and pulling data science ideas into new spaces. That's going to be a great place to be. Analytics and visualization is something that is not going to be automated for a long time, and we have a lot of data science that needs to be brought to less technical people. Data engineering is super hot right now. So if you think about where people were spending all that time, they were spending all that time on like pulling data and cleaning it. Well, we're starting to automate that, and the people automating that need to understand data science, and they need to be really strong developers. That's a space that I think is really hot right now, and will be hot for 5 or 8 or 10 more years until the tools get good enough to where anybody can just hook it up and not think about it. And then going deep, right? So you can always get a PhD and study recursive Bayesian estimation for self-driving boats, right? And be the only person who knows the most in the world about that. All right, so that's it. Here's a bunch of ways you can keep in contact with me. I'm around. I'm happy to answer questions. Uh, so I think my UCSD email is going to work this summer, but last summer it disappeared on me. So this is my work account also. Same thing at Gmail. It's the same everywhere. Um, if you do the LinkedIn thing, I'm happy to have you connect. And I know some people that I might be able to help introduce you to or whatever. Um, and I have a personal website with other stuff too, if you want to do that. But the big thing is, as you are thinking about your data science career or whatever, if you reach out with questions, I'm happy to do it. So that's it. I rushed a little, but I got it. So thank you so much. I got to be honest, I really was apprehensive about this class, and it turned out to be one of the more memorable ones I've ever done. The pandemic and the remote and the like, what a 10 weeks, and the fact that you all learned as much as you did and rolled with the punches, I really appreciate. So thank you so much, and hopefully I will see you on campus someday. Thanks.